and we should decide which one based on the maximum profit in each case. So it is a two-stage dynamic programming, very simple case. So the optimal profit for each one of them can be obtained, and the results will be compared. So for weight, since we don't incur any transaction cost or transaction fee, we can consider the saving that we make as the profit. So it is the same. So I'm just using this for simplicity. So C is the saving in transaction. And now we have these simple definitions. So in a specific period of time, the opening price is Y0, and the closing price is Y3, and the maximum price is Y1, and the minimum price is Y2. So out of these four variables, we know the first one, because that's the point that we are making the decision, so the decision point, and we don't have the other three. So the purpose of the forecasting the regression model is to predict these three variables, 1, 2, and 3. And we use the price that we know, the rate that we know, to normalize these three variables. So that's very simple. And so the first variable is the maximum increase in the price, the second variable is the maximum decrease in the price, and the last variable is the change of the price. And the forecasting model is just simple linear, multivariate linear regression. The dependent variables are Y1, Y2, and Y3, and all the information available up to the decision point can be used for predicting. So they are predictors. And we can use principal component analysis to make our model more robust. So this is generally the model. It is not sophisticated, it is very simple linear model. And the variables are like this. So we have our predictors, we can have as many as we want. And we have n observations. We have n observations. X is the design matrix, which is for training the data that we collect. And x0 is the test values to test the model. Beta hat is the regression coefficients that we obtain based on the design matrix, and R hat is the matrix of residuals, and its covariance is sigma hat, which is just basic statistics. And using multivariate regression model, we can have y a function of, actually y has a distribution based on the result of the regression. So the result of regression actually specifies the mean value for y's, and also we can obtain the variance for y's using the regression results. So here's a question. What is the optimal profit if we buy? So the optimal profit given a specific take profit level can be found like this. So we have the probability of meeting the take profit level times the take profit level plus the probability of missing the take profit level, not reaching the take profit level, times the expected level of profit that given that we didn't meet the take profit level. That is the expected profit, obviously. And the challenge is that the trade-off is that if you have higher take profit level, you have more profit, but it will be less likely to meet that take profit level. And that's why we need an optimal take profit level. So, and of course, for the other side, for sell position, the formula just mirrors the buy position. So we have take profit level for the sell position as Q. And we can, what we need to consider is the hard part in that formula is to find the expected profit when we didn't meet the take profit level. And we can find it based on this. So this is the expectation, and this is the result. For also for the take profit of the sell position, we have something